Assalamualaikum. My name is Amirul Shah. My metric number is CE210138. So I would like to present about software calculation. I'm from group 6 and my section is from section 8. So here is for the first which define the I will use Maple software. For the first is define the cylindrical coordinate, set the cylindrical coordinate which is r, theta and z. We use the polar coordinates. So the next one is define the equation of the hemisphere in terms of cylindrical coordinate hemisphere. So square root 25 minus r power of 2. So the next one will be we define the surface area integrate. So the integrate was square root of 1 plus differentiate hemisphere r power of 2. R determined as x plus y in bracket. So define the region of R. The next step. So R must be less than 3. Why we convert to polar coordinate, which is if we didn't convert to polar coordinate, we will get the wrong answer, which is 2/3 pi. We're supposed to be get 10 pi. So set up the soft of the double integral, which is the topic of we use the method we use in this question, which is double integral. So result is the integral f multiply r, and r is 0 till 3, and the theta is 0 till 3 multiply by pi. So assume r. So here the result. The common for the result is display the result. So here it is. So set the cylindrical r theta square root negative r power of 2 plus 25 in bracket. The next one, the answer for the comments for the next step is power of square root negative r power of 2 plus 25, and for the furthermore step is square root 1 plus r power of 2 and over negative r power of 2 plus 25. R will be less than 3, and we got the answer is 10 pi. That's all from me. I will let pass to the teammate.
Hi and Assalamualaikum warahmatullahi wabarakatuh. I will continue the demonstration on question 2b. First, we get the function of z equals to square root 4 minus x squared. The r is in the xy plane, and the x is from 0 until 1, y is from 0 until 4. So this is the intervals in terms of the x and the y later on. First, we need to find differentiation of dz over dx and dz over dy. From above equation, we get dz over dx is equals to, in bracket, 4 minus x squared to the power of 1 over 2. Next, we differentiate this equation. We get 1 over 2 times 4 minus x squared to the power of negative 1 over 2 times by 2x, negative 2x. So we solve this equation. We get negative x over square root of 4 minus x squared. So dz over dx to the power of 2 is x squared over 4 minus x squared. Meanwhile, dz over dy is 0 because in z terms we got no y terms. Hence, the differentiation of z with respect to y is 0. So dz over dy to the power of 2 is also 0. dz over dz is 1. So dz over dz to the power of 2 is also 1. Next, we get double integral of r square root dz over dx square plus dz over dy square plus dz over dz square dA. And we get square root of x square divided by 4 minus x square plus 0 plus 1 dA. Simplify the equation, we get square root x square divided by 4 minus x square plus 1 dA. Next, we're going to simplify this equation. We must multiply 1 here by 4 minus x square divided by 4 minus x square. Then we get square root of 4 minus x square plus x square over 4 minus x square dA. Then we get square root 4 divided by square root of 4 minus x square, and we get 2 over square root of 4 minus x square dA. So the surface area is double integral of r 2 divided by square root 4 minus x square dA. Intervals, line integral from 0 until 1 in terms of dx, and line integral from 0 until 4 in terms of dy. So we substitute all the information into the surface area. We got double integral 0 until 4, 0 until 1, 2 over square root of 4 minus x square dy dx. Next, we're going to bring 2 to the outside of the line integral, and we get dy over square root of 4 minus x squared dx. We solve the integral, we get y over square root of 4 minus x squared from 0 until 4 dx. We substitute the y equals to 4 and y equals to 0, we get 4 over square root of 4 minus x squared minus 0 dx. So we got this equation here. We're going to bring 4 to the outside, so 2 times 4 is 8. Integral from 0 until 1 dx over square root of 4 minus x squared. We know that integral of dx over square root x squared minus x squared is also inverse sine x divided by a. So x is from 0 until 1 and a is 2 to the power of 2, which is also 4. So we substitute the equation here. We get 8 times by inverse sine 1 over 2 minus sine 0 over anything is 0, so sine inverse 0. We get 8 times by 1 over 6 pi minus 0. So we got here the last final answer is 4 pi over 3 squared. Next, I will continue this presentation to verify the manual calculation whether it is correct or not using software. So now we will continue the demonstration in software implementation to verify whether the manual calculation is correct or not. So first we're going to use Maple, and then we're going to use Matlab. So first we need to differentiate z in terms of x. So we insert d over dx, square root of 4 minus x squared to the power of 2. Then we get x squared divided 4 minus x squared. So we're going to repeat the same process in terms of y. So d over dy square root of 4 minus x square bracket to the power of 2. And we get 0, which is true because in z terms there is no y. So differentiate y, we get 0. Next, we're going to differentiate dz in terms of dz, which is we're going to get 1 to the power of 2 is also 1. Next, we're going to insert all this information into the equation down below. So first we need to put square root x squared over 4 minus x to the power of 2, which is dz over dx squared. So we're going to plus with 0 plus with 1. Then we get square root of x squared over 4 minus x squared plus 1 dA. So this is the information we need to implement the software calculation using Matlab later. So without wasting any time, let's open Matlab. Alright, before I run this program, I want to explain first. First, we need to define SYMS in terms of x and y, input function in terms of fxy from the equation we get from Maple earlier. Display function is to display whether we put it correct or not. Next, a is equals to lower limit of x, b is upper limit of x, c is lower limit of y, and finally d is upper limit of y. So we have to use this formula, which is the Matlab, to define double integral. So q is equals to integral to bracket function a, b, c, and d, close bracket, semicolon. Then we're going to display q, which is display our answer. So let's run. Input function in terms of function handle, which is this xy. Click enter. Lower limit of x is 0, upper limit of x is 1, lower limit of y is 0, upper limit of y is 4. We click enter and we get 4.1888, which is 4 pi over 3. So this software implementation and manual calculation is the same, hence the calculation is proven correct. So that's all from me. Thank you very much. I'm an icon, man. I'm a girl about a 10. I should fuck her in the Benz.